While Derek Briggs lifted the shield of Canadaspis, Simon Conway Morris was busy with an array of less enigmatic worms, polychaetes and priapulids. Don't worry, that isn't the topic of this video. I promised you lots of arthropods this year, and I intend to make good on that. Remember this, cutie pie? Harry Blackmore Whittington. Something important about Whittington is that when he began his work on the Burgess fauna, he was already known as the world's leading expert on trilobites. In the late 70s, Whittington was close to accepting his fate as a Cambrian oddball connoisseur. That is, he always chose the strangest creatures to investigate: Opabinia, Morella, Yohoia, and now Naraoia. Stephen Jay Gould describes Naraoia as one of the most striking and attractive Burgess organisms, and he asserts that this photo of it is the best unretouched photo ever taken of a Burgess Shale organism, at least as of 1989. Something tells me, though, that this opinion still would not waver if he were alive today. If you've ever seen a drawing of Naraoia, you may have assumed it was a trilobite. Surprisingly enough, though, Charles Walcott originally classified it as a crustacean. Naraoia compacta is less than 5 centimeters long at maximum and is assumed to be fairly flat. Its carapace covers its 14 pairs of legs as it scurries around the ocean floor. 2 antennae peek out from beneath its headpiece, sensing its surroundings in lieu of eyes, which it does not have. The name Naraoia refers to the Narao Lakes near Kicking Horse Pass. Why would a place be called Kicking Horse Pass, you may ask? Because in 1858, geologist James Hector was kicked by a horse there. So naturally, the area was dubbed Kicking Horse and the lakes Narao, which means hit in the stomach to the indigenous Nakota, who currently reside in Alberta and Saskatchewan. This seems a good place to acknowledge the fact that geologists working on the Burgess Shale in the 19th and early 20th centuries relied heavily on the knowledge of Indigenous peoples when exploring rural Canada. I do not feel qualified to speak on this much at present, but I would like to learn more about how Indigenous perspectives shaped scientific findings, as I'm sure that many contributions went uncredited. Furthermore, I yearn for that alternate reality in which science is done holistically, to understand and serve the natural world, incorporating many perspectives at every turn. The current field of North American paleontology was originally built on white men going on pleasure hikes and taking whatever they wanted from nature, and we as scientists are now left to mend our bond with the world we live within in order to reach true conclusions about our environment. As much as I love learning about these topics and am grateful for the knowledge made accessible by scientists, I cannot help but feel that we are too greedy, that perhaps we were not meant to know such things if the cost is the removal of every stone as it was naturally placed. Naraoia fossils only show the carapace, which is clearly divided into 2 parts, head and body. Appendages stick out from the edges but can barely be seen. For 70 years, no solution to this problem presented itself. Then, one day, Whittington realized that the answer to this problem was right in front of him. The Burgess fossils are 3-dimensional. Imprint fossils are usually sliced across the top, which means that each specimen you see has a counterpart that shows the mirror image. Slicing off another layer can reveal a different part of the fossil underneath. Walcott assumed that everything was squished completely flat during the mudslide, leaving no evidence of 3-dimensional structures, but this was not the case. Whittington carefully sliced off another layer of a Naraoia fossil, revealing her insides and her appendages. These diagrams were made using camera lucida, which is an analog technique used to trace 3-dimensional objects onto a sheet of paper. This drawing of Naraoia reveals important information about how her limbs were structured, as well as the appendages on her head: 1 pair of uniramous antennae and 3 pairs of feeding appendages. These characteristics struck Whittington as undoubtedly familiar. They were shared by trilobites. As you may imagine, this made Harry Blackmore Whittington, Earth's trilobite expert, quite excited. I could attempt to describe this excitement myself, but I cannot resist sharing with you Stephen Jay Gould's interpretation of events. Trilobites are his babies, and he had just given birth to a stunning and different child. What makes Naraoia so stunning and different? Well, if you've ever looked closely at a trilobite, you may have noticed that it is divided into 3 parts. These are called the head, the thorax, and the pygidium. It is also divided into 3 parts across the body called pleurae, an arrangement referred to as trilobation. Lots of arthropods are divided into 3 parts lengthwise, but having lobes like this is special. Naraoia does not show this structure at all. She does resemble a trilobite, a very simplified version, but her carapace is not divided the same way. Still, Whittington was convinced she was a trilobite. He may be a bit biased, but her appendages did follow the trilobite design, and as we learned from Bronchiocaris and Canidaspis, appendages are quite telling when classifying arthropods. If the trilobite expert claims Naraoia as a trilobite, who are we to disagree? If you expected this story to end similarly to Canidaspis, you would be wrong. Many other researchers have agreed with Whittington's assessment that Naraoia is a trilobite, though descended from a primitive line that branched off long before the trilobites we know of existed. Some assessments have placed her with the mandibulates, like Canidaspis, or the chelicerates, like horseshoe crabs, but she is generally accepted as a trilobite relative. So, what have we learned? Hopefully you found Naraoia to be a fascinating and lovely subject of study, though I don't think anyone could love her quite as much as Gould or Whittington. Upon reflection, I feel that the main lesson learned here today is that Charles Doolittle Walcott is always wrong. Though, if you were in his shoes, I doubt you could do any better. Paleontology is not a solo sport. It requires a combination of different perspectives, sometimes accumulated over the course of several decades. It does not have to be that way though, and thankfully, modern research has employed group collaboration much more than our pioneers did. Having multiple backgrounds and perspectives working on the same project is valued and allows us to gain a better understanding of a subject without waiting 70 years for that eureka moment. Paleontology, like most academic subjects, demonstrates the importance of diversity, from the species abundance of the Cambrian explosion to the varied scientists working hard at uncovering their secrets. The Cambrian was a time of experimentation, with evolution taking many different approaches to creating fit organisms and crafting ecosystems that swiftly came and went. Most of the species from the Cambrian have no living descendants, but trilobites survived in some form for 270 million years, only going extinct at the end of the Permian along with 95% of all species on the planet. While their design may be a failure by today's standards, it was a success for a longer amount of time than any of us can fathom, illustrating the ever-changing nature of existence. Thank you so much for watching and for your continued encouragement. Making these videos has been a joyful escape from the uncertain world in which we live in at present, and I have greatly enjoyed learning with you so far. Thank you for joining me, and I look forward to our next encounter, which will focus on a more popular Burgess anomaly. Bye! What the fuck?